What we want to do here at Virginia Tech is creating a research and education program that really makes a difference, that's not focused only on identifying the issues, but also providing solutions. We're not only looking to work with people who are really, really good at what they do from a disciplinary context, but also are willing to listen to other scientists in their scientific discipline to see how it impacts them. Microplastics represent a very, very complex problem for our Earth, for our environment, for us. The issue is that we really don't know how the system or how we as individuals or animals actually are fully impacted by it, because our understanding of the impact is relatively low. So if you go to the marine environment, a lot of the issues that we have there is that we cannot really observe the environment directly because it's hidden under the water.
One of the things we've become interested in are nanoplastics. So these are plastic particles in the environment smaller than 1 micron or 1,000 nanometers. These are really difficult to sample and also to characterize. So the Center for Coastal Studies has allowed us to put together a team that can build autonomous underwater vehicles equipped with a sampling apparatus that can go out and specifically sample nanoplastics from real environmental systems like lakes, estuaries, and coastal zones. So with this new device that's in development, we're going to be able to get unprecedented sampling from real events like storm events that happen, where we may see large movement of plastics from the land into these coastal zones where they may have negative impacts on ecosystems.
One of the most pressing challenges in the field, tied into the progression of our field as a focus, is that contaminants are never seen as agents of global change, meaning that when we think about biodiversity loss, we think of climate change, we never really factor in that contaminants play a role in that because of their global distribution, that they're impacted or they're influenced by human activity, and that they affect various types of biota. Contaminants, whether personal care, pharmaceuticals, or microplastics, are agents of global change. And so our understanding of our field has to incorporate that aspect to it. Coming to Virginia Tech stood out to me because one thing that I lacked, especially within my formal education as a researcher, is collaborating. I always was in these small labs where I worked independently and rarely collaborated, and I knew as a researcher that's something I needed to change. In Virginia Tech, they really emphasize collaboration and they make it easy. Through the Coastal Observatory Center and various types of groups on campus and working groups, I've been able to collaborate with various scientists from different backgrounds.
Through the Center of Coastal Studies at Virginia Tech, the Coastal Hazards Lab has had an opportunity to fund undergraduate research related to both earthquake and tsunami research that we commonly do in the lab, and also this exciting new microplastics project that we've been doing on the eastern shore of Virginia. And we've been covering the kind of sediment analysis part, where we go and collect the cores, we analyze the grain size of the sediments and process the samples. And Dr. Gray has worked with his undergraduate students to look at the microplastic concentration down core, so we can get an idea of how microplastics are accumulating in marshes and how their concentration has varied through time. The Coastal Hazards Lab at Virginia Tech is involved in the new Cascadia Region Earthquake Science Center, and my lab will be leading the paleoseismology working group, which is going to focus on building these longer-term, thousands of year timescale records of earthquakes and tsunamis at Cascadia, so we can build a better understanding of what has happened in the past there and start to build this knowledge of the future and what we can expect from future earthquakes and tsunamis.
We have a wonderful geosciences department, which is my home at Virginia Tech. We also have the Academy of Integrated Science.
We have a really good partnership in the research arena with the Coastal Studies Center, because faculties from the center and faculties from the Academy of Integrated Science, they work in partnerships to solve environmental health problems. For example, nowadays, microplastics is a serious issue in the environment. There's a lot of microplastics found in the oceans, for example, that eventually not only affect the ecosystems of the ocean, but really will end up affecting humans, and simply because of our exposure. So how this changes on the ecosystem translating human diseases, and how we can detect them, treat them, and even solve the problem of having those particles out there that they are so dangerous.
For these kind of complex problems to answer or find solutions to these complex problems, it's not just important to engage scientists and educators who are very good at what they do in their discipline. It's also to find people who are able to understand that it is important to understand other scientific paradigms. It's important for a chemist to understand biology. It's important for a geoscientist to understand math, and math to understand geoscience. It's important for me as a geoscientist to understand the medical impact. And this capacity building is a personal experience for folks, and we need to have the right people to do that as well.